G'day, this is part 3 in the video series of plotting from C++ using Python. In this video, I'll go through how the functions are actually working that are doing the plotting, that are generating the data files, and then also invoking Python to do the plotting. I'll also get into some of the differences between using binary output files over text files, and some of the pros and cons to those two. Okay, so here we are back at the code. This code is essentially doing exactly the same thing that was done in the previous video. However, there are a few additions that I've made, but nothing that's going to change what the code is actually outputting. So one of those additions that I've made to the code is I have this timer structure. It's not that important. This is just here so that I can actually time how long the binary writes and the text writes are. Towards the end of the video, we'll get into that. You don't have to understand how this is working. It's just a timer. That's all that's going on here. And in fact, I'll just collapse it so that it's kind of taking up less room in our code. So as mentioned, we are also looking at outputting to a binary and plotting the data for both 2D and 3D plots. So, it's essentially the same as the text, save and plot 2D, except instead of a text file being output, we're outputting a binary file. All right. So that's what these two additional functions are here. And we'll kind of get into, the differences in the timings of those functions. So all four of these functions here, they're essentially all doing the same thing. They just require slightly different syntax to actually perform what they need to perform. But if we just go and have a look at one of these functions, you can understand the basic principle of how the function is working. So we're going to go and have a look at the 2D output function that we've got here, and we'll actually just walk through. But the same reasoning for all the other three functions, it pretty much all follows the same reasoning. So here we are down at the text function, at this 2D text. This text save and plot 2D function. So we kind of have an idea of what we need to pass to the actual function for it to do its operations, as was mentioned in the previous video. So I'm not going to get into too much about the inputs to the function. But essentially, if we just follow this function down line by line, we can see, as I mentioned at the start, I've got this timer here. Okay, this doesn't need to be in the function. And in fact, the script that generally I give out, I don't include that in there. That's generally removed. But for the purposes of seeing the differences in the text and the binary writes, it's there, but it's not necessary. We have this, we convert the actual size of the array, right? That n array size, we're converting it to a float. You don't have to do this for the text files. However, for the binary files, it is necessary to convert integers to floats, just so that reading those binary files doesn't become too much of a hassle on the other end. If everything in the binary file is the same kind of data, it makes it a lot easier to actually read the file. These next lines here are just necessary to actually open a file and to kind of tell C++ that we're going to write to a file. Okay, so that's what these two lines here, they are completely necessary to actually set up a file. And then this for loop here, this is the actual where we actually write to the file. Okay, so if you're following, if you have a look at these lines here, these are the lines that are actually outputting to the file. Okay, they're very similar to if you would use cout to write something to the console or to write something to the terminal. Right, it follows a similar format with the two less than signs required for outputting things. Okay, that's what these are. These operators are here. So again, these is just, they're just writing. These lines here are literally just writing to the file. Now, the thing that's at the bottom of the for loop here, this file close, this is really important. Sometimes you can get away with not closing a file correctly in a code. It is highly not recommended that you don't close files after you've finished writing to them, because it can cause problems, and in this case it will. That's just because we are going to, immediately after we've written to this file, we're actually going to read from the file in Python. So it's really important that we do actually close the file after we've done writing to it. so that Python can actually open it and access it. So that's what that line's doing there. It's closing the file, which is really important. We then come down here, and this is actually the line that is going to call the Python script that's going to do the plotting. It's going to read in that data file that we've just written to, and then it will plot the data that was in that data file. So I make this string here, okay, and then I pass this string to this function that I've written, this system command call, okay. Now we'll start with this string. Just a few comments on this. If you're familiar with Python and you've run Python from the terminal, maybe you can recognize that this string right here, this is how you would invoke a Python script from the terminal, okay? So if I came down to the terminal, right, if I came down to here, and I wanted to run a Python script, right, all I would need to do is type Python and then, my script, and I can run that script from the terminal, where I would just hit enter and it would run that Python script. So essentially it's the same thing here. This string is what I want to write to the terminal to actually do my operation, okay? So as I mentioned in the second video, right, if we come back up here to our folder system, you can see plotting scripts, and I've got that plotting script, that plot2d underscore text.py, right? So that's what that file is there, okay? So I'm saying Python, and then I'm saying run this script. Okay, and it's going to go and it will run this script. So this string here is actually passed to this system command call. Okay, so you can essentially kind of think about the operation of this function is essentially I can write something as a string, it will interpret it, and it will actually perform like if I came down to the terminal and actually wrote to the terminal. Okay, so if you didn't want to use Python to do your plotting and you wanted to use maybe nuplot, this line would be the only thing that needs to change in the C++ script. You would just, instead of using Python, you would invoke nuplot, or you could invoke MATLAB from the terminal, and it would all work the same. Okay, so if we just go quickly and have a look at this system command call function here. So this is right down the bottom of the code. There's a little bit going on here, right? We have to convert a string to a character because that's what the system wants, right? This system function that I'll get into in a second. But these three lines here are essentially taking that string that we've passed in and converting it to a character type. That character is then passed to this function called system. So this is an inbuilt function in C++, and this is the function that's actually essentially performing how the terminal performs. Okay, so it's taking what we wrote in that string character, right? It's sort of up here. This was in a slightly different function, but it's still the same sort of style. Okay, it's taking that string, all right, converting it to a character, and then it's actually passing that string or that character set to this function called system. And the system function is the thing that's actually doing the terminal operation. That's invoking Python and calling that script. So if we come back up here to the text save and plot2d function that we were at before, right? So we essentially have to open a file, we then write to the file, close the file, and then we invoke Python through the terminal, and that is what actually allows us to do the plotting. The Python script reads the data file in and then plots the data in a plot and saves it, as was shown in the previous video. Okay, so that's generally the basic way on how all of these plotting scripts work, right? If I went to another one, it would be a very similar process. Open the file, write to the file, invoke Python through this system command call function. So if we come back to the main, it's worth making a comment on actually the time differences between writing to a text file and writing to a binary file. So I have the four functions here, right? I've got the 2D and the 3D, and then for the texts, right, writing to a text file, and then I've got the 2D and the 3D writing to a binary file. So if we come down here and we actually compile the code, right, and then we run the code, it will actually output how long each one of these functions took. Okay, so the first two here, right, this is writing to a text file for both 2D and 3D data. So the first one was for 2D data, right? Took about 1400 milliseconds or 1.4 seconds. And then the second one here, this is outputting 3D data to a text file and then plotting, right? That took about 5700 milliseconds or 5.7 seconds. Okay, that's for a text file. And then we come down here in these bottom two, these are the binary write files. Okay, so the 2D write, which is this first one, if we have a look at that linear line, maybe we haven't seen too big of an increase there, right, in the speed. They're pretty similar to one another. Kind of indicating, maybe the data just isn't quite big enough that we would see a dramatic performance increase in terms of writing from a text to a binary file. But still, if you're writing a lot of files out, that 0.2 second difference that you're seeing there, that can add up if we do a lot of writes for just a linear file. On the other hand, if we come down and we look at this final value, this is the binary write for 3D data, right, for that matrix data. So this is almost the same amount of time as it took for the linear write here, okay? And it's almost it's almost 5 times faster than what it was to write to text. So we're seeing a dramatic increase in speed for a 2D data write using binary instead of text. Okay, so in short, binary is a lot faster to write to. The files are a lot faster to write to than in text. But some of the disadvantages that I'll kind of get into now are that the binary files are almost incomprehensible. Okay, so if I come up to a text file, right, I can see, I can actually see the data. I can understand what it's actually output. There's a lot of data here, and it's not ideal. I can't actually understand it as a human. It's just all numbers, and that's what plotting is for. But I can look at the numbers, right? The numbers make sense. If I now come over to the binary files, okay, and I actually open them up, you can see here that it's incomprehensible. It doesn't make any, it's not human readable. You can't understand any of this stuff that has actually been output. Okay, so that is one drawback of the binary files, is that they aren't human readable in the sense that you can open them up and see what's inside them. You sort of have to know what is in there to read from them. Okay, so in the Python scripts, because I generated the files, I know how they've been laid out. I know what's in there, so I can tell Python, this is the data that's in there. Whereas a text file, I can just come over and I can kind of look at it and I can get a better gauge of, telling Python, this is how the format is, read it in this fashion. But for the binaries, it's a lot harder to do that. Now, another advantage, though, of binary is if I just toggle back and forth between these, you can kind of see down here, Visual Studio Code is giving me a warning here. And that's because this text file is quite large in size. And it would actually, it's kind of telling me like, hey, I'm doing some clever stuff to actually make this file visible to you, but be aware that this file is quite large. The binary files, on the other hand, are not at all large. That message is just remaining there from before, but the actual size of these binary files is relatively small compared to the text files. So if we go back to the C++ code, if these numbers here, right, if the size of these arrays were very large, not only would it take a much longer for you to write that data out to a text file, but the text files themselves would be a lot larger compared to the binary files. So you kind of have to keep that in mind when your data sets are getting quite large. Okay, so in summary, right, you can pick whatever you want for the binary or for the text files. It doesn't how you want to output them in C++. It's totally up to whatever you want to do. In general, binary is faster and the file sizes are smaller, but their disadvantage is they aren't really human readable. You can't click on them and see what's actually inside them like you can a text file. So maybe when you're first starting out, it's probably better to stick with text files, and then when you get a little bit more confident in C++, you would most likely switch to binaries. So if you have any further questions, about how the code is working or about how the functions are working, you can leave a comment or contact me, and I can help you out further. Thanks.